This is our Ruyer reading group. We're continuing our reading of Cybernetics and the Origin of Information, picking up from page 100 of the translation. So we're in chapter 6. The last couple sessions, I think we've been talking about, this whole chapter is about his criticism of sort of we started a new chapter last time, if I remember correctly. So he's talking about, this chapter is introducing his distinction between what he calls negative anti-chance and positive anti-chance. So if we start from this concept of anti-chance first and then make the distinction. So in some sort of chance setup, flipping a coin, turning a roulette wheel, etc., you have, a set of possible outcomes. And if the system, or the setup or whatever it is truly a chance setup, then each of these outcomes should be equally probable, or the distribution of outcomes as you run the system over and over again should match some kind of statistical distribution. So in the case of the coin flip, if the coin is actually fair, then as you flip the coin more and more times, it should get closer and closer to a 50-50 distribution of heads and tails. And then, so supposing you find a coin on the sidewalk and you want to know, is this coin fair or not? And you flip it 1,000 times and you get heads 1,000 times in a row, you would most likely conclude that this coin is not in fact fair, that there's it's based on the sort of distribution of mass within the coin or some other property of the coin. It's sort of rigged to come up heads every time, or much more often than tails. In this case, you're from the results of this 1,000 times coin flip test, you are inferring that there's some property of the coin that sort of biases it towards landing with heads up. Obviously, this is a very simple example, but here in this case, we're like the sort of general form of inference here is from an observation of a non-uniform distribution of the results, or a distribution of results that deviates from the expectation in the case where the coin would be fair, and then given that deviation, you infer that there's some sort of physical property of this coin or of the system in general that brings about this deviation, and this is sort of like the general form of inference behind this sort of anti-chance concept. So whenever we find some set of outcomes of some sort of process that we consider to be different than what we would expect if that process were sort of a chance process, then we infer that there's some kind of physical mechanism or physical connection underlying the difference between the chance, the expectation if the system were governed by chance, and then the observed result, which is different from that. And so this sort of concept of anti-chance has an important connection with the concept of entropy and the arrow of time, or the thermodynamic arrow of time. So he talks about, he gives us another sort of example, is you have a billiards table, you have a bunch of white balls, set up on one end of the table, on one half of the table, and then you have a red ball on the other half of the table, and then you fire, you hit the red ball towards the white balls, and of course they all sort of bump into each other, and they're all set in motion and they're bouncing around everywhere, and so they would scatter sort of all over the table. So if you sort of film this proceeding, this is like it just looks like a normal set of events where someone fires the red ball and into the white balls, and the white balls bounce around. But then if you play that same film in reverse, you would start with the white balls bouncing everywhere, and then the red ball somewhere in the middle, also bouncing everywhere. And then as you watch the film, the white balls would all gradually sort of move over to one side and come to a stop, and the red ball would shoot off to the other side and come to a stop. And so if you were to watch this film in reverse, at the beginning, when all the balls are just sort of bouncing randomly, it would look normal. But then as you start to see all the white balls sort of spontaneously move over to one side and stop, and then the red ball go firing off to the other side, this would look completely unnatural. Like you would see this happen, and you would just like immediately infer that something non-chance, some anti-chance operation was governing this process. And so it's the same, like any type of entropic process, so any process where entropy is increasing, as soon as you sort of play the film in reverse, it's something that you would that just looks unnatural, where you can immediately see, as you watch the recording going backwards, you can immediately see that this is a recording going backwards and not just a physical process that happens to be running in the opposite direction. So you can think of like, burning a piece of paper. You have, a piece of paper, you have flames, and then you have a bunch of ashes. If you watch that recording in reverse, where you have a bunch of ashes that sort of spontaneously reassemble into some burning paper, and then the flames disappear, and then you have a perfectly fine piece of paper. This is obviously, like, watching that recording, you would obviously be able to see that this is a recording being played backwards, and not a recording of a process that just happens to be the reverse of the burning operation. But then, so this is sort of the general idea of anti-chance, that, like, there are certain connections, certain physical connections within objects in general that bring about certain types of anti-chance. So if we observe something that deviates from the expectation of a chance outcome, then we infer that there's some sort of mechanism, some physical connection that is bringing about that seemingly unlikely event. But then he points out, so he makes this distinction between positive and negative anti-chance. So we, in the case, like the first case I mentioned of the coin you find on the sidewalk, where you flip it 1,000 times and get 1,000 times, get heads 1,000 times. Here, you don't necessarily know what what exactly it is that makes the coin come up heads every time. You can guess that it's probably something about the way that the mass of the coin is distributed within the coin that results in heads coming up every time. But it could be some elaborate magnetic mechanism that you didn't notice, like surrounding that piece of sidewalk where you're flipping the coin, or there's like the coin is actually like connected to some kind of wire that you didn't notice that is like controlling it to make sure it lands heads every time, or it could be anything. Of course, these are all extremely unlikely hypotheses for why it's landing heads every time. But all you can say just from your observation is that there's some physical connection, some mechanism that is bringing about the deviation from the chance outcome. But then in another case, you might actually be able to find what the mechanism is. So if you flip the coin and you get your heads 1,000 times outcome, and then you observe it more carefully, and you find that there is this magnet controlling the outcome of the coin flip somewhere, and like you can see the magnet, then you would be able to not just say there's something bringing about this anti-chance outcome, but you can say this specific mechanism is responsible for the anti-chance outcome. And of course, in biological entities, in living beings, there are many systems that have this kind of property of controlling, of the sort of mechanism property, that like in the sense that they ensure that certain ions pass through a membrane and certain others don't, for example. And without the sort of functioning of this biological machine, the ions would just sort of pass back and forth across the membrane in such a way as to equalize the concentration and charge on the two sides. So it's only because there is some sort of biological machine operating to pump ions from one side to the other that you get this unlikely distribution where you have like a charge in a neuron, for example. So you have these like biological machines that produce an unlikely outcome. But what Ruyer points out here, and this is, I think, connected to some of his arguments in the previous chapter about information, is that this kind of machine, even a biological machine, it might be sort of counter-entropic in the sense that it prevents the concentration of these ions from just equalizing across both sides of the membrane, for example. But it doesn't really explain the you can't sort of explain the creation of this membrane in the first place, just in terms of a machine that would sort of set things up that would produce this anti-chance outcome. Like you can maybe go back one step or several steps in this way. Say like the biological machine we're looking at now is itself the product of some other biological machine, but like the whole, organism as a whole, the whole setup, the whole system of biological machines that make up the body of an organism can't itself be explained in terms of a biological machine. Or if we take the billiards table example, like you might observe the sort of backwards recording outcome where all the white billiards balls gradually come to a stop on one side of the table, and you might find that there's like some sort of secret mechanism of magnets underneath the table that is controlling them or whatever, but that secret mechanism of magnets was not itself set up by like an even bigger system of magnets or some other bizarre mechanism that sort of controlled the process. So at some point in that chain, there was something that was not itself a machine that put the machines in place to bring about this anti-chance outcome. So this is like, I think, one of his sort of standard like forms of argument is that you can maybe explain one machine in terms of another machine, and maybe you can keep going up that chain, 3, 4, whatever steps. But at some point you reach, you can't explain machines purely in terms of other machines that would set them up. Even when you're talking about biological machines, at some point you need to get either the person who built these artificial machines, or in the case of biological entities, you get like his sort of psychobiology sort of framework. You have a form or a living form that is responsible for organizing these biological machines into the whole system that is an organism. So this is like his general sort of pattern of argument, is that we, tracing one machine to another only gets you so far, and you need to get like at some point you need to get past the sort of machines that are the product of other machines sort of mindset. Okay, so I think that we can pick up from there. So we're on page 100 at the heading Connections and Consciousness. So Angus, if you would like to read from there.
Yeah, no problem. Oh, we're on I thought we were right. Yeah, that makes sense. Connections and consciousness. There remains a difficulty. If connections, whatever their nature, provide the positive element of anti-chance, they must have common characteristics, and it is unclear what relationship there can be between mechanical connections and conscious connections other than. As long as these relationships are not clarified, one will always be tempted to give priority to mechanical connections and reduce conscious connections to them. This temptation must be cut short. Of these two types of connections, it can be shown that it is the conscious connections that come first. There are only two possible philosophies of connections in relation to consciousness. Either consciousness is only an accompaniment to the play of physical connections and it is ineffective, or consciousness is the connection itself, and therefore, where there is binding effectiveness, there is consciousness, or quote-unquote absolute survey. One cannot have two different standards. There is no conceivable middle ground between epiphenomenalism and what we will not call panpsychism, for the word has taken on two fantastic meanings, but rather the theory of consciousness as the essence of all connections and as a universal quote-unquote informant. Intermediate concepts, whether in biological organicism or in the finalistic behaviorism of psychology, are only vain subtleties, hiding a profound indecision of thought and the internal contradiction of a quote-unquote square circle. Clark L. Hull, for example, following Edward C. Tolman, believes that he can reconcile the recognition of an organism's de facto finalistic behavior with a behaviorist and cybernetic system. Regarding consciousness, he writes, quote, "Is its existence denied? By no means. But to recognize the existence of a phenomenon is not the same thing as insisting upon its basic, i.e., logical priority. Instead of furnishing a means for the solution of problems, consciousness appears to be a problem needing solution," unquote. However, he does not realize that claiming to explain consciousness is to deny it, or to make its existence appear as a vain glimmer. Consciousness cannot be explained. One can deny it practically by granting it a mere ghostly reality, or on the contrary, by making it the effective principle of all connection information. I'll just read the next section because that was very short. Mnemonic return. The priority of conscious connections already appears in the intermediate case of memory. Although memory, whether organic or psychological, does not increase information, it reconstructs a form according to modes that cannot be reduced to the action of mechanical or dynamic links, to the action of elastic bands or tubes in any form. The return in space of a specific adult form, starting from a germinal cell, cannot be explained in the same way as the return of the red ball held by an elastic band. This is because the structure of the germinal cell is simpler than the adult form. No quote-unquote string represented by a physical tracing or the action of a special chemical substance for each structural detail can unite one by one the structural details of a cell and those of the adult organism composed of billions of smaller cells in terms of their chromosomes to the germinal cell. Despite the reluctance of biologists, it is becoming increasingly clear that mnemonic return does not take place in our space, but from a world of types toward our space along a hypergeometric dimension. Embryological regulations, which are so extensive and striking since they succeed in making a normal form even after cutting, disruption, deficit, excess, or transplantation, are evidence that regulatory information is at work in development. Now, it is perfectly certain that this cannot be mechanical feedback involving recurrent circuits and conductors located in space, since by definition, such circuits do not yet exist in an organism that is precisely in the process of making the assemblies that will later serve for its adapted behavior, and which does not yet have a nervous system. It is no less certain that it is not dynamic feedback either, using fields of force and not circuits, since experiments have condemned Vogt and Gertler's hypothesis, as well as Gestaltist interpretations of organic regulation. It therefore remains the case that it is a matter of regulations analogous to those of axiological feedback, controlled by a transspatial ideal. The regulatory ideal in biological reproduction is mainly mnemonic. The new organism does not, strictly speaking, invent its form, which is that of the species, but is only capable of those small inventions that are regulatory harmonizations. But it is indeed a transspatial ideal, and the appearance of the form in space-time is an epigenesis, like invention itself. Something similar to this return of type from the transspatial world to space also occurs in psychological memory, since red integration from an evocative fragment does not occur in a quote-unquote domino game, as was previously believed, but through the perception of meaning or a certain expressiveness. I think this is a really interesting idea, in especially this mnemonic return section about the process of embryogenesis as a kind of remembering of this transspatial ideal or transspatial virtual form. I wish that he went into more detail because he, basically just states that it can't be the case that that embryogenesis is sort of mechanically explicable. But I know that that's not, he has other books on embryogenesis and biology, and it's not his. It's not really what he's setting out to do here. But the association with memory is also interesting in Bergsonian sense. I think that Bergson would be sympathetic to them that embryogenesis is a kind of action of remembering of some virtual memory.
Yeah, I guess the like the memory thing you can connect to sort of like the sort of Platonic questions about memory, in the sense that if you suppose that memory is just a matter of sort of like the memories are sort of encoded in the brain, for example, there's engrams was the term that was used in like the early 20th century, that there's like some sort of encoding of the memory as a physical property of some portion of the brain. Then you have this question of how exactly does the brain retrieve that memory? Like how do you if you say I want to remember what happened on my 6th birthday or whatever, then you need to have some procedure for, finding that specific engram in your brain, that specific, structure that encodes that memory. But then the question is like, how would you find that memory without already knowing without having that memory already available to you? Like, how do you go like, okay, this is the right engram, the one I was looking for, unless you already knew, what the content of that memory was supposed to be. And so maybe like if you want to compare it to like a computer memory system, you like in various forms of computer memory, there's some sort of index where like you have, say, a file name, and you can say, I want to retrieve the file that corresponds to this name, and then you have some sort of index. Here's all the file names, and then based on, you match the file name that you were looking for, and then it finds, where in the whole storage system are the registers that correspond to this file name. But it's not obvious, at least, that human memory has something like a file name index that like you just sort of, enter a query that says, 6th birthday party, and then, some other, system in your brain goes through an index and goes, okay, here's where the engram for my 6th birthday is. There's no indication that there's a structure that resembles that sort of index in the human brain. But I mean, of course, it's always possible that, maybe there is something like that. We just haven't found it yet. But in the case that he talks about, like embryogenesis, I think it's one of his sort of like core examples, because you have like in an embryo, the structures are precisely not there. There's no there's definitely not an index in the embryo that says, when you want to build an eye, here's the program for what, or the blueprints of what the eye is supposed to look like. In his other book, the psychobiology book, he gives like one of his sort of primary examples is an amoeba, because, and this is actually, again, a pretty kind of shows a lot of foresight, I think, because it's only in the last like maybe 10 years or so that there's been a lot more research into cognition happening among like single-celled organisms, for example. But he talks about how an amoeba, is not just a sort of biological machine that responds to stimuli coming in. It sort of hunts, it finds its food. It has like a sort of coordinated behavior in the sense that it moves in a certain direction. It avoids say like a chemical that that's like noxious to it, etc. It does things that make sense in pursuit of certain goals. I mean, obviously, or we have no reason to think that it's sort of like contemplating the nature of life, or solving mathematical problems or whatever in the sort of sophisticated form of what we would call cognition. But it's not just sort of a machine that gets stimulated by certain inputs and then produces a certain output. It's like taking in different kinds of information from its environment, making a decision based on that information and pursuing a certain goal, in light of that information. And an amoeba, as he points out, has no nervous system. It's one cell, so it doesn't. There's no nervous system within this amoeba, but it's capable of doing these sort of cognitive tasks and goal-directed behavior and so on. So if an amoeba can do all this without a nervous system, it's not obvious that the presence of a nervous system, or that in multi-celled organisms, in animals, for example, the nervous system is sort of the essential component for something like cognition. And in general, like given that an amoeba is capable of doing this without a nervous system, it sort of brings into question the idea that you need to have this like preset structure present for something like goal-directed behavior or cognition to happen. And so, of course, his position is that the cognition comes first, and then the structure is a result of that cognition. So in the case of embryogenesis, it's there's something at least analogous to a cognitive process that is responsible for the whole production of or the development of the embryo, and then as the embryo develops, it in the case of say a fish, it it develops a nervous system, but the nervous system is a product of the cognition and not the other way around.
Yeah, it's really interesting, and there are interesting similarities with Bergson's understanding of biology. And Bergson sees tendency as prior to and generative of structure. So, at least as I understand it, kind of the master tendency for living beings for Bergson is this tendency towards indeterminate or symbolization. It's the same. But then this tendency would kind of individuate as a subtendency. In the right kind of milieu, the ability to see and navigate a lighted milieu, which of course would not be independent of the existence of like some kind of photosensitive group of cells and some kind of regulatory pathway, which through the use of or the release of morphogens during embryogenesis would enable the creation of something like an eye. But the tendency to vision, I think on Bergson's understanding, is prior to complexification of something like the development of the like camera-like eye over evolutionary time. It sounds like something similar might be the case for Bergson, or sorry, for Ruyer, cognition, nervous systems.
Yeah, I think this is again just sort of the same type of argument as I was describing in the sort of intro, that you can have mechanisms, these biological machines, of course in the development of an embryo there's these morphogens, there's all kinds of gradients of chemicals that sort of set up like the head to tail gradient within the embryo that eventually makes one end of the embryo become the fish's head and the other end become the fish's tail. So of course there are these sort of biological machines going on within the embryo, but at the same time you can't you can sort of keep going up the chain of like this biological machine is a result of this other biological machine, but you eventually sort of run out of machines to build the other machines. Like you have to at some point get to something that is not itself a machine that sort of organizes these machines into a body, into an organism, and rather than just a sort of assortment of different machines. And this is what his sort of general form of argument is, that you have to get to this this sort of absolute overview, I guess is the translation, this sort of like form that is not itself sort of formed by something. It's this kind of immanent form. It's itself the form of something, rather than being taking on form as a result of some process. And so this is like his just general form of argument that I think he's sort of running through in different contexts. So in his other book, he has, or sorry, in some of his other books, he talks about this in the case of embryology. In this book, he just sort of alludes to some of these ideas. But here he's talking about it in the case of cognition and information. Okay, so let's go on to the next bit. I can read this one. Return of type and microphysical bonding. While it is impossible to understand mnemonic return of the normal type by invoking mechanical guidance, the opposite is not only possible, but is necessary according to the most certain results of contemporary science. Every bond, liaison, or elasticity must ultimately be interpreted as a, quote, return of type, unquote. Despite the complications due to various A-structured bonds in metals, elastic resistances and cohesive forces are reduced, according to W. Russell and M. Bourne, to electric forces identical to those involved in chemical reactions. The same organic fibers, for example, myosin or keratin, where it is the HNCO affinity in the protein chain that sometimes closes and sometimes, when the fiber is stretched, allows the ring to open. So here's the chemical formula: COCHRNH, The electrochemical bonds, whether heteropolar or homopolar, are reduced to a, quote, tendency towards redintegration, unquote, or, quote, reconstruction of a type, unquote. The A ion, sodium ion, which is electropositive due to the loss of an electron, attracts the Cl ion, chlorine ion, which is electronegative due to the gain of an electron. But why does the chlorine atom tend to capture an electron, and why does the sodium atom tend to lose a peripheral electron? If not because the normal type of the M shell is to have 8 electrons and not 7 or 1. Similarly, in the chlorine molecule, each of the 2 constituent atoms shares an electron in such a way as to reconstitute the structure of a noble gas, whose outer shells are quote-unquote normal. The 2 chlorine atoms remain linked because they tend to separate either along the A or A prime lines or along the B or B prime lines. This sounds like it's a reference to a diagram, but it doesn't correspond to the diagram on the page, so I'm not sure what's going on there. Separating along the A prime lines, one of the 2 atoms would be normal with respect to the outer electron shell, but it would be in electrical imbalance. Separating along the B or B prime lines, both atoms would be in electrical balance, but they would be abnormal with respect to the completion of the electron shell. Oh, yes, yeah, so the diagram is at the bottom of the page. Sorry, I didn't see that. Yeah, so I don't know how you describe this, but yeah, I would just say, for anyone listening, go find the book and look at the diagram on page 103. Okay. It is very curious that the formation of molecules of various types, and therefore the variety of substances in the universe, is made possible by the discordance between the requirements of 2, quote, typifications, unquote. Electrical balance between nucleus and periphery on one hand, and filling of the peripheral shells on the other. Generally, when the, quote-unquote, electrical type is satisfied, the, quote, shell-filling, unquote, type is not, and vice versa. When there is coincidence, as with the noble gases, the complex structuring of substances is immediately halted. On the other hand, the possibilities of complexity are maximized when the antagonism or quote-unquote deficiency, boiterie, between the 2 types is most pronounced. That is to say, when the electrical balance is only achieved when filling is at half its value. This is the case with semiconductors, intermediate substances between metals and metalloids, such as carbon, silicon, and germanium, substances whose chemical activity is at its maximum. Douglas Henderson and Lesser Blum would really have some justification here for seeing a curious fitness in the architecture of things, without which the complexity of molecules and therefore of organisms would be impossible. A perfectly analogous phenomenon is observed in the superchemistry of atomic nuclei. The antagonism, the quote-unquote deficiency between the 2 types, is found in another form. This time it exists between nuclear forces on one hand and electrical forces on the other. For example, considering nuclear forces alone, a carbon nucleus would immediately capture an alpha particle and become an oxygen nucleus, since the transmutation would take place with loss of mass and release of energy. But the electrical repulsion between the alpha particle and the carbon nucleus prevents transmutation, except in rare cases where the speed of approach is sufficient. Without this electrical repulsion, carbon, as well as oxygen and all distinct simple substances, could not exist, and the entire universe would quickly be reduced, as it may have been in the beginning, to a single nucleus. For the formation of atoms as well as molecules, the shift of electrical and other forces plays the role of a sort of stairway, which breaks the continuity of the slope and allows for the existence of distinct substances. In any case, the formation of atomic and molecular structures results from a sort of effort toward the reconstitution of the normal type. One can challenge physicists to explain or describe chemical bonds without invoking, in one form or another, the ideas of quote-unquote normal, quote-unquote type, quote, typical redintegration, unquote, and quote-unquote tendency, or without using a conditional verb, which amounts to the same thing. It is doubtful that this challenge can be met because there is no functioning here according to a structure, but rather a reconstitution or tendency toward reconstitution of a structure, as in organic or psychological memory or invention. This section goes on for a bit, so I think I'll stop here. So he makes reference here to this to the staircase or stairway. This is going back a couple sessions when he gave this sort of example of you have a staircase with gravel at the bottom of it, and then of course the most likely outcome in this situation is just that the gravel just stays where it is and at the bottom. But if there's a storm or some kind of disturbance, some of this gravel can be pushed or spread in such a way that it ascends the staircase at least a few steps, depending on how big of a disturbance, how strong the storm is, for example. So just by being sort of randomly blown around, a certain amount will get onto the first step, a bit of a smaller amount will get to the second step, etc. So the fact that there's this staircase here, if you had the other situation where you had this gravel pit with no staircase, it would the gravel might be disturbed by the storm, but it would then just fall back into another arrangement that would be sort of equally probable of a pile of gravel with no particular order about it. But the fact that there's the staircase here means that the disturbance gets sort of frozen in a sense where you have this unlikely arrangement of gravel on the stairs as a result of the disturbance. But it's the stairs that make it possible to keep the gravel at this unlikely position of being sort of separated from the whole mass of gravel. And so he's sort of comparing this situation to, or he's using this as a sort of analogy for the way that these chemical bonds and atomic structures are formed through these like interaction of kind of competing tendencies that bring about these different forms, like different elements, for example, in the case of chemical bonds. So you can, it's only because there are these, different structures that that are each sort of pushing in different directions. Or sorry, maybe I put this in a different way. It's only because there are these like different directions in which the atom is being pulled. So having certain electrons in its shell, for example. It's only because of this that there is such a thing as elements that have different properties. So carbon versus chlorine versus sodium, etc. So in this case, it's not that there is some sort of mechanism that makes it that makes sodium capable of bonding with chlorine, for example. It's there's some sort of a kind of tendency to form along this sort of pattern, this return to a type, as he describes it, that makes it possible for there to be something like a chlorine atom, which we can sort of picture as a tiny machine. So, I mean, this is one of his more, I guess, unusual metaphysical commitments, but he treats atoms, subatomic particles, etc., as analogous to living beings and to minds. So the fact that there is this kind of structure of an atom is a result of something that is analogous to the way that a living being takes on structure in embryogenesis. So yeah, we've been sort of joking about this as saying that electrons have souls, just the same way that humans do. And I think he might actually sort of agree with that statement, although he probably would not use that exact language. But yeah, so of course this is like I think it would take more to defend that statement than he provides us with here. Like he's just sort of presenting an analogy here. He's not sort of arguing for this position. That's not sort of the purpose of this book. But yeah, he's again he takes the periodic table, for example, as being the result of a kind of absolute overview that brings about the form that that atoms can only take on these specific forms of sodium, chlorine, gold, iron, etc. So yeah, an atom sort of is the result. The atom that we can observe and measure its properties, etc., is the result of the same kind of absolute overview as the fish resulting from the embryogenesis, or the mathematical theorem resulting from the psychological process of invention. These are all sort of analogous processes for Ruyer.
Yeah, I think this is the first time I've read one of his. I've read him directly making these claims about atomic and subatomic phenomena, and the way that it's phrased here, at least, seems more reasonable than I think I had kind of assumed his position would be. The idea that there are these really competing physical tendencies, which kind of in their interaction, at least as I understand it, give rise to this like global atomic tendency to return to a type, which is like a memory, but not in the sense in which like a human being would consciously recollect something, but just an atom would be sort of like I mean, it doesn't seem like he's arguing that it would be conscious in the same way that a human being conscious. It's just that the form taking and the maintenance of in an atom is, yeah, as you said, analogous to the way memory can hold form, and we can order our surroundings on the basis of some way that we remember them to be, as in the example of the cards, or the dominoes, I can't remember what it was that he gave in a previous section.
Yeah, I think it was the deck of cards. So yeah, you can, like, as a person who, knows what patterns you can find in a deck of cards, you can like take a deck that's been shuffled and you can sort it by, suit and, number, etc. You can take this unpatterned, or this, presumably after shuffling this presumably sort of random assortment of cards, and you can impose a pattern on it, or sort them into a sort of patterned form. So in this case, of course, you're taking some pre-existing form of, say, like you know that there are four suits, or that there are 13 possible cards within each suit, etc. Like you have this existing structure that you're just sort of sorting the cards into. So it's not really a sort of invention in this case. But when you're thinking of, say, like you're doing a scientific experiment, in this case you're trying to find a pattern that you don't know already. You like, I don't know, are looking at the development of these embryos, and you're trying to figure out what factors are involved, what chemical substances are sort of responsible for this element of the development of this embryo, and you have to sort of try different variations and try to find a pattern, etc. So it's a much more sophisticated process than just sorting cards into these pre-existing categories. So here in this case, you're not just sort of retrieving these existing categories and classifying the cards into those categories. It's as if you were like presented with a deck of cards for the first time and had to figure out which ones belong together, or like what pattern you can find among these cards. And of course, what pattern you would find would depend on what exactly you were like, what interest you had in patterns, like what you wanted to use those patterns for. So yeah, there might be many, like you could probably find infinitely many different patterns that would make sense for some purpose, but for other purposes would be meaningless. And likewise, in the case of the embryo, you might have certain patterns that you can find that are relevant to certain goals or certain purposes and not to others. But yeah, so in the case of the atoms forming, these different elements, so he wants to sort of get away from the idea that there would be just a sort of like static, when we look at the periodic table, it's easy to think of it as this sort of like static set of boxes that atoms just are sort of distributed in this like kind of brute fact manner, that like it just happens to be the case that there are these 120 whatever elements in the universe, and it just happens to be the case that this atom is in this box, and that's just sort of a brute fact. He instead wants us to sort of reconceive this fact that this atom is belongs to this element as something analogous to he's a bit more cautious here than maybe in other places, but like analogous to the way that when you're conducting that scientific experiment, you sort of classify the embryogenesis instances that you're observing into different categories. So here, in the case of the person conducting the scientific experiment, you're sort of like, you're performing this, very sophisticated cognitive operation. You're taking into account all kinds of different factors. You're bringing your own, prior knowledge about how embryogenesis works and genetics and all these other things. You're bringing these into the whole system, so it's infinitely more complicated than the case of the atoms, where it's just the sort of simple interaction of these like two different tendencies. But already in the case of the atoms, the interaction of these two tendencies, because of the way that they're sort of structured, it allows for these 120 whatever different elements to form. And so here we can think of the elements not as these sort of like static boxes that atoms just happen to be sort of grouped into, but rather as like the stable points resulting from the interaction of these different tendencies, that because these tendencies are sort of oriented in this way, that they have this sort of nature, as a result of that, there are these possibilities of a stable state of an atom, and then those stable atoms that are in that stable state will have these properties as a result of being in that state. So yeah, it's definitely, so he, like a few pages ago, he had sort of mentioned the term panpsychism, which is sometimes applied to his work, but he sort of rejects it here in the sense he thinks there's sort of these fantastic consequences, and I think he might be thinking of the idea that an electron would just be conscious in the same way that a human being is conscious, or an atom would be conscious the same way that a human being is conscious. And he's of course not asserting that. He sometimes sort of expresses himself in I think a strong form, maybe to sort of provoke a reaction, to sort of like push the reader out of a sort of comfortable habit of thought. But I think the sort of general idea is that the way that atoms sort of remember the types, remember that they can become oxygen or carbon or whatever, is analogous to the way that a human being can remember their sixth birthday party. That in each case, it's not through the functioning of a machine that sort of pre-exists. It's through this process of taking on form that you remember something, or that the atom remembers what the structure of carbon is that it's taking on.
Yeah, it's really interesting. He's mentioned, and I think he goes on to mention Gestaltism a few times in this section. And I wonder if Gestaltism seems to be one of the like intellectual tendencies he's distancing himself from, along with cybernetics. And I wonder if one of the differences between Ruyer and Gestaltism is that for Ruyer, the form of the atom is produced by these tendencies, or the atom as a kind of form-taking operation. I don't know. Maybe it's just that the processual emphasis, that it is an activity of form-taking rather than kind of a pre-given form. And yeah, I guess I'm just wondering if that's what he sees as the difference in Gestaltism.
Yeah, that's a good question. I'd say I don't know enough about Gestalt psychology to really have a good sense of what the distinction is here. But in general, I think he assimilates Gestalt psychology to the kinds of cybernetic or mechanistic approaches that he's criticizing, and he thinks of it as sort of like a more sophisticated version of like sort of the cybernetic explanation that he thinks is insufficient. So he talks about when he's talking about those different sort of demonstration toys that had been set up, the artificial tortoise and so on. He mentions the homeostat, which doesn't have a sort of set of preset mechanisms in the same way that the artificial tortoise does. It has this sort of dynamic self-regulation property. It involves electrical circuits that sort of balance each other. But he sees this as more or less just a kind of sophisticated version of the artificial tortoise. So in this case, we don't have this sort of finite set of preset circuits that are involved in this feedback self-regulation process. You don't have like like this one circuit that is directing the tortoise towards the light source, for example. You instead have it's as if you just took this finite set of pre-existing feedback loops and just sort of blended it out into like a continuous feedback process. But you haven't really gone beyond the sort of idea of having like a preset feedback system. It's just that rather than having this like finite set of feedback loops, you have like this sort of continuous feedback process. I'm not sure if that's a good explanation, but so I think he sees this as not really getting beyond the same idea of like a machine. It's just that in this case, the machine is not made of like pre-existing, parts like gears and pulleys and so on. It's the machine is sort of constituted by these electrical sort of interactions that have this continuity about them. But at the same time, the homeostat, for example, can only ever return to its equilibrium state, even if it does so, by means of this continuous process that is not sort of preset at the outset. The whole sort of orientation towards returning to equilibrium is itself preset in that. So the homeostat can't like sort of autonomously decide that it's not going to return to equilibrium anymore. I think that's sort of like the general distinction that he wants to make between his approach and the Gestalt sort of approach.
Thanks. Yeah, that's interesting. One other thing that is not entirely clear to me, but I guess I just kind of want to keep it in mind as we continue reading is, what the relationship between physical forces and these remembered or invented forms. Because at least in this case, it seems that these two typifications, as he puts it, the like imbalance between the positive charge at the center of the atom and the negative charge at the periphery, and then also the tendencies of the electrons in the shells. The imbalance between these two physical forces is kind of what gives rise to the, I guess, global tendency to return to type. But that global tendency also doesn't seem to be reducible to the physical tendencies. So it's, I don't know, it seems like he's not claiming that there are just like these kind of memories of what it is to be an atom floating out there in the void, independently of like physical processes that actually give rise to like the form taking of an atom. But at the same time, the form, the sort of return to type, is not, it's, I don't know, maybe something more than the, I guess, sub-tendencies that it requires in order to come about.
Yeah, so like in the case of embryogenesis, for example, he's like I mentioned earlier, he's not going to deny that there are machines, biological machines involved in the development of an embryo. What he's denying is that the overall process of embryogenesis can be explained purely in terms of the functioning of machines. Obviously the development of an embryo into a fish is something far more complicated than the stabilization of the subatomic particles into the structure of an oxygen atom, for example. So here, like in the case of the atomic structure, there's this like limited set of I think 120 whatever, I can't remember the exact number, but this relatively small set of possible stable forms, and even among those forms, some of them are only stable for a short amount of time, like some of the radioactive elements. So there's this limited set of possible forms, but of course the like possible fish stable forms at the output of an embryogenesis process is like vastly more complicated or much larger than this very limited set of elements. And part of that is the fact that the development of the embryo is not just sort of this interaction of these two relatively simple tendencies, but it's like, far more different tendencies. And then there are sort of like sub processes of development that produce machines that themselves, operate in certain ways and bring about certain results, etc. And so like you have this sort of nested structure of machines that arise in the course of the developmental process. And of course, like the fish embryo, or sorry, the fish as it develops, you have many cells appear, and each of those cells is itself a kind of biological machine with its own, functioning. So the ability for something as complicated as a fish to arise requires this sort of nested hierarchy of developmental processes.
I can go ahead and read the next page or so.
Maybe we can do one more and then discuss and wrap up.
Yeah, it sounds good. Were we at the interpretation?
The interpretation of valences. Yeah.
The interpretation of valences by wave mechanics does indeed shift the mystery of typical red integration. For example, the filling of the atom's peripheral shells is reduced to a case of standing waves, but the mystery is displaced without being cleared up. The sharing of electrons in a molecule certainly does not resemble the fitting together of particles as it appeared in the early Bohr or Ruyer diagrams. The electrons are not localizable in their quote-unquote octet, and their sharing represents the formation of probability of presence. The electrons lose their identity, and a certain energy of exchange or interaction appears, borrowed from the individual energy of their constituents. This energy of interaction can be imperfectly represented as an energy of resonance. If two pendulums react to each other, their coupling creates a quote-unquote combination frequency. But this is only an image whose inadequacy is recognized. The energy of exchange is unrepresentable in our space. The quote-unquote combination frequency is an indescribable periodic change of state, where some quanta of action that are fundamental and have no analog at the scale of ordinary physical phenomena always intervene. Therefore, one should not be fooled by the geometrical schemas of the atom and the molecule. There is no simple and familiar way to represent the typical structuring of the atom. When we have a container of a determined shape and a limited number of non-deformed balls, the various ways in which the balls can be arranged in the container are also limited in number, and the resulting figures are, in the broad sense, typical. There is something coarsely analogous in the structuring of the atom. The filling of the electron shells as peripheral electrons are added superficially resembles the filling of a container with non-deformed balls. But we are sure that this image is deceptive. The particles are not balls, and the shells of the atom are not containers. The interpretation of Bohr's orbit trajectory as a standing wave orbit, where the length of the orbit must be divided into a fixed integer number of lengths, should even less suggest a simple filling phenomenon. In the atom, there are no available places, only available states, calculable according to the possible combinations of the numbers. The electrical or magnetic filling of an atom is not spatial. The image of filling a container with non-deformable balls only becomes relatively true for the assemblies of ions determining the structure of crystals and the phenomenon called coordination. To study the different types of coordination, the image of a ball surrounded by other balls, either of the same diameter as the first or increasingly larger, is usable and fruitful. One can successively arrange, according to their relative diameter, 12, 8, 6, or 4 peripheral balls around the central. But this type of structure is of a derivative in superficial order. Ionic bonds do not constitute true molecules, but only crystals. On the other hand, the ionic bond, taken in itself and not in terms of the coordinations it determines, obviously cannot be explained in turn by a phenomena of filling according to simple geometric laws. In contemporary theories of bonding, we clearly reach a limit with structural explanation. Explanation by structure presupposes a whole grammar: space, distance, proximity, individual particles, continuity, and kinematic, which is inapplicable to structural explanation. The atom is a structuring action, not a functioning structure. Structural explanation gradually gains a certain value only we reach the crystalline scale, and already partially at the molecular scale. It is indeed true, for example, that in the water molecule, the two hydrogen atoms form with the oxygen at an angle slightly greater than 90 degrees, and that this geometric angle explains certain properties of the water molecule. But the structuring action of the atom itself obviously cannot be understood by yet another spatial structure under pain of a vicious circle. This action requires a red integration of type that can only be conceived on the model of memory or invention. An organism also partially functions according to its structure, but its very structuring is obviously not functioning according to a structure. "Quote unquote differentiating" cannot be reduced to a quote functioning according to differences, which by hypothesis are not yet present in space. In this respect, the fundamental entities of microphysics resemble organisms. An atom is not like a self-distribution system or a mechanism at our scale, whether made by humans or not. Under the influence of Gestalt theory, it is often still believed that there is no middle ground between a kinematic mechanism with sliders and a Gestalt. It is believed that every structure is necessarily one or the other. This classification precisely misses the most central and important case, which is that of a structure formed according to a transspatial type and hypergeometric bonds, whose model can only be found in the action of a conscious and medium. The structure of the atom, quote unquote, arrives in space according to abstract compatibilities or incompatibilities, irreducible to a step-by-step function. Yeah, so the point about kind of the modeling of the position of electrons in shells, the electron shells of an atom, on the image of filling up a container with balls. This seems to be the point you were making about the periodic table, basically, that we can't take the kind of finished result of the structure, which we have organized organized and visualized in this way that is useful for understanding the behavior of the atom. We can't take that kind of heuristic to be primary. There's sort of I don't fully understand the quantum processes he's talking about here, but these processes are not themselves. They don't resemble the model of the atom as kind of a little planet orbited by like electrons. And yeah, the point that the organism and the atom can't reduce, their behavior can't be entirely reduced to the structure, because that structure has to come about in a way that can't just endlessly refer to another structure. I mean, maybe like a reductionist counter argument that, if you reduce the elements to kind of their most simple constituents, then you'll have something like an atomic structure that gives rise to the complex structure of the organism. But I wonder if for Ruyer, you need to be able to explain the kind of the relevant scale of the structure. So the structure of the oxygen and the two hydrogen atoms that combine to compose the water molecule kind of need to be understood on their own terms and at their own scale. And similarly, the substructures or the global structure of the organism, because the organism functions in accordance with its global structure, needs to be understood at its own scale. At that scale, it can't be understood in terms of another structure, but needs to be understood in terms of the process that brings that scale of structure about.
Yeah, so like in the case of this model of the atom, for example, so like in the early 20th century, you had the solar system model of the atom, where it's just, the tiny nucleus with the little electrons circling around it. And yeah, so this is what an atom looks like. It's a little solar system. And then of course, as quantum physics started to be developed, the sort of inadequacies of this model became more and more apparent. But the point that Ruyer is getting at here is that it wasn't replaced by like a different sort of mechanical picture that, it's not a solar system, it's actually some other type of machine. It was something that is not really visualizable in space anymore. So like the positions of the electron in the atom are not like sort of positions in space that you can just sort of stick an electron into. They're more like possible forms of resonance of a set of pendulums, for example, in the way that the analogy that he presents here is that, so like when you have coupled pendulums, they can only sort of like after a certain amount of adjustment to each other, they can only sort of oscillate within certain sort of sets of patterns, like multiples of each other's frequency, etc. So like the atom can likewise only stabilize with certain configurations of electrons, but that doesn't it's not we shouldn't picture it as like a puzzle that would be missing a piece, which the electron would be like the missing puzzle piece that you just sort of stick into this structure. Instead, we can picture and you can't really picture it exactly, but we should think of it as like the configuration of the atom in which there's the certain arrangement of electrons is analogous to the configuration of the coupled pendulums that can only oscillate in a certain set of arrangements of frequencies. So yeah, this is like the more sort of abstract conception that he's trying to like push us towards. And for him, like even in the simple case of the atom that can only have certain configurations of electrons, we should think of this not as like a set of pre-existing arrangements that the atoms are just sort of slotted into, but instead as the result of this absolute overview kind of process that is analogous to the cognitive case where someone invents a solution to a problem. Or in some cases, the solution to the problem might be retrieving what your memory was of what happened on your 6th birthday. So it's not you're not sort of inventing something in the sense of like creating something that didn't exist before, but your process of getting that memory is itself a kind of like micro invention. Okay, so yeah, we're pretty much at time, so we can end here for today. Yeah, we only have a few more pages left in this chapter, so we might finish this chapter next time and start the next one, depending on how quickly we go through everything. Yeah, so I guess how many more chapters do we have left? Oh, we still have a fair amount, and then there's also the like supplementary chapter at the end, which is fairly long. So yeah, we still have we're about halfway through the book at this point, a little more than halfway through.
Okay, that sounds good. I guess it's a bit early to start thinking about the next book.
Yeah, I have a few ideas in mind, but we can wait for a bit, and as we get closer, we can discuss that more.
Yeah, that sounds good.
Okay, yeah, thanks for coming out, and hope to see everyone who is remaining involved next time.
That sounds good.